Good afternoon, everyone. My name is Bastien Leblanc. I'm solution architect for AWS based in London, working for travel and retail customers like Expedia or River Island, which I'm pleased to be joined by Charlie Wilkinson, head of architecture at River Island. Today's session is building highly scalable retail order management systems with serverless. That's a lot of words. So you probably heard a lot of serverless. We'll touch upon a lot of how it's interesting and important for customers to run that and how they can build their retail order management systems. So I would first start with going through serverless introductions to set the scenes on the service that River Island used and typical use cases that we see at AWS. And then Charlie will dive deep more on the challenges of their current architecture and why did they move to a serverless architecture, a more event-based architecture. And we'll try to find at least 5 minutes for Q&A, or after the session we can have a discussion, of course. Serverless. So you probably have heard this term this morning because we see a tremendous interest in the industry. And but what does it mean for us at AWS? What does it mean? It goes in 4 characteristics. First, it means no servers. Okay, you get it. But no servers means that you don't have anything to deal at the operation systems level. You don't have to SSH in your box anymore. You don't have to patch. You don't have to upgrade. Just take care of your business services. Second characteristic, it scales with usage. So when request comes in, no matter you have 1 request per minute or tens of thousands of requests per second, AWS will take care that this service will adapt to handle the workloads. We do the auto-scaling for you. You just use the service. The third characteristic goes along with the other. Never pay for idle. You probably have been used to do capacity planning in your enterprise applications, build your servers to handle the peak workload, your night batch, your Prime Day, your Black Friday. So you end up using about 20% of your servers most of the time, and this 80% of unused capacity is just sitting there idle, just not bringing any value for your business, which is completely different with serverless because you just pay for what you use. If you have a large night batch, if you have a large promotion day, we just handle that. And the fourth characteristic is built-in availability and fault tolerance. So we have this concept at AWS called regions. One region is composed of multiple availability zones. And when you build a service on AWS, you have to build it multi-AZ. You have to make sure that your service is available on multi-availability zone to handle this high HA, high availability fault tolerance. In serverless, it's fully managed. We handle that for you. Let's start to dive deep in a bit more in a few services that River Island used to build their order management system. So the first one is a compute service called AWS Lambda. You can run code in Node.js, Python, Java, C#, and now Go. The important point here is that it's event-based compute, which means that the compute is triggered only when you have an event. An event can be a technical event. Something is off, is down, is up, something happened. But it can also be a business event. And you can think of having streams of events. So in the River Island case, it would be order coming through, changes in one order can trigger this new code. And this code can be anything. And you can connect to the AWS services, to an external API, or even your on-premise application if you have the right network connection. But again, the most important part is that it's an event-based architecture. So that's good, but customers have asked us how to build more complex architecture, more complex application using AWS Lambda. And that's how we came up with step functions. That is a service that enables you to orchestrate your application with wait events, with conditions, with business or technical conditions. And you can see on the left how it looks in the console. One important point here is that it handles gracefully the errors. Technical or business errors can be managed by step functions, pushing the errors to a dead letter queue or something else. If it's a technical error, you can retry or build. And so you can build a more complex business workflow using step functions. And the last service I wanted to touch point on, and that was heavily used by River Island, is DynamoDB. It's our NoSQL database in the cloud. It's fully managed. What do we mean by fully managed database in the cloud? It means that when you want to create a new table, you just select the region, the table name, the throughput that you want on this table, the number of requests per second, and do you allows us to auto-scale this request per second, and that's it. And you have a database, fully multi-AZ, flexible, secure, and auto-scale based on request. To finish, I wanted to touch point on a few use cases that we see at AWS from our customers using serverless. The first one's quite straightforward. You can host a website, host an e-commerce website, from a static website on S3 to a more complex application like Flask or Express. Second use case is data processing. This one is very interesting because, again, you can think of your data pipeline very differently. You used to have like a night batch running the whole data in one ETL and then dumping down that elsewhere. And now you can think of this as events, and every piece of information coming from the streams, coming from an event, a new order, new click streams, can be processed in pretty much real time with even more heavily batched next to it. And the third use case is AI ML Alexa. So for example, when you ask a question to Amazon Alexa, it's usually an AWS Lambda function triggered. And it powered a lot of chatbots with Amazon Lex. And the last important use case is backend systems, which is running all the backends of your services in a very decoupled, very event-based mechanism. And that's exactly what River Island has done, building their order management systems on serverless, fully managed. And I let Charlie explain a bit more on how they used our services to build this order management. Thank you, Charlie.
Bastien. Thank you. Cool. Hi, guys. So I'm Charlie. I'm the head of architecture at River Island. The first thing I'd like to say is that River Island is perhaps not an organization you might typically immediately associate with ultra cool new tech. So I'm hoping to dispel that myth a little bit for you guys. Really what I want to do is talk a little bit about, as a business, we've recognized that we needed to undergo a massive digital transformation. We've also realized that adopting and embracing digital isn't just a case of having the most shiny widgets on your website. It's actually, it's a real grassroots exercise. We're looking very, very closely at the way that our business fundamentally operates, the really, really core processes that we have as a business, and how we bring those into the new digital age. And really that's, today I'm going to be talking a little bit about the first step on that journey for River Island. So, first, a little bit of a history lesson. So really this is a case of explaining where we've come from. So like many organizations and many retailers out there, we've come from a heritage of a big old Oracle estate. Fairly common pattern, and that has many drawbacks or features that are perhaps less than desirable that many of you guys will be familiar with. We're going to focus in on the way that we process web orders. So it's a fairly familiar flow, I'm sure, to most of you guys. Our website produces web orders, and at the moment, or historically, we were consuming those in batches. So we get like a group of 100 or 1,000 or however many orders have been placed in the last X minutes since we ran the scheduled job to go and fetch them. We slurp those up and we stuff them into our core merchandising system, into Oracle or ODBMS, and that's really become a hub. It was designed as a centralized hub for all of the key business operations that were occurring throughout the business. Fairly standard pattern historically as well. From there, those new orders, again in batch process, they would get stuffed into our warehouse management system and equally into our OMS order management system, which is where we do the packing and dispatching. Again, pushed through in batches on a scheduled job. Once we've executed all of our picking in the warehouse, we've run a pick wave. We'll get those pick results again in a big batch and actually route them to the order management system so that they can then be dispatched. You'll note that it flows through that core merchandising system, again, just following that hub and spoke model that we had adopted in the past. Our order management system used to then execute the payment capture, which was we needed to do that because we only capture payment once we've actually shipped the goods. Again, fairly standard pattern. So then we've got a load of dispatch results. Again, big batch of them. Every X minutes we run a cycle job and consume those up through the core merchandising system again at that hub and spoke model, and ultimately push those dispatch events up to back to the website so that we can notify consumers and say, hey, your order's on its way. Fairly standard. Worth noting is that all the stuff that I highlighted in red is actually happening through DB links. It's all PL SQL hidden away inside the databases. It's not actually files flowing around, which makes it that much harder to get at that information. And then over the top of this, we have to have this sort of overarching orchestrator system that basically executes all these weird batch jobs, and it's a really, really sort of, what's the word I'm looking for, sort of beautifully oiled Swiss watch of components. I can see a few of my colleagues laughing at that. To actually organize all of these complicated batch routines that are running. It's executing shell scripts, it's doing all sorts of gubbins. So this is probably familiar to many of you. What are the disadvantages, though? Well, the most obvious one is that we've got a whole load of really exciting business events, pick events, dispatch events, all sorts of stuff going on in here that we can't get at. It's all tucked away in these Oracle databases and in these database links and PL SQL routines. They're just not available. Excuse me. Another issue is adding new features. Doing something new with those business events is really, really difficult and high risk. You touch one system here, you've got to do a full regression test of the whole estate, which is very, very expensive and very time consuming. And as such, big projects are generally avoided or too expensive to consider. We've also got a lot of single points of failure here. In fact, almost any one of these three Oracle databases, if they're down, you're screwed, you can't do anything. Equally, the orchestrator dies, same story. You've got a whole load of people stood in the warehouse twiddling their thumbs with nothing to do. And obviously, that always happens on Black Friday if it's going to happen. Sod's law. So it has its flaws. What I would say is that we do respect it. It's runs a £1 billion business. It's not to be snarked at. But it certainly has room for improvement. So, worth calling out also, batch processing. Everything in our heritage estate is, primarily is driven by batch processes. Now, I hate batch processes. It's a bugbear of mine, and there are several reasons for that. Firstly, you've got peaky CPU usage, right? You're only really, your databases are sat there doing nothing most of the time until your schedules run, and then everyone's familiar with the midnight schedule that makes the servers go mad. So that's a pain. You're paying for servers that you're not using most of the time, as Bastian alluded to earlier. One dodgy input breaks the batch. This is a common problem. It's really, really difficult to defensively code around batch processes, and generally speaking, you get that unexpected character or whatever it is, weird promotion that the marketing team decides to put on, and suddenly your batch is broken. But not only that, usually that dead batch will block all the other ones behind it as well, because your schedule is interrupted, it's waving its arms, I don't know what to do about this, and the whole thing's stuck. And again, one broken step in that chain that we had up earlier, and the whole house of cards falls apart as well. So not ideal. And then on top of that, your data's not really that timely. Yes, you can run your cycle jobs every 15 minutes or so, but when you've got like 15 jobs in a row, that compound time is potentially quite long as well for your data to actually be updated and reflected. So it's not exactly very fast either. So let's talk a little bit about the architectural principles that we've come to think of when we were looking to address this and make a better solution. Ultimately, we came up with these two guiding objectives. Firstly, we really, really want to surface our business events. All those business events that are tucked away in our estate, those things need to be available. I want to be able to do something new and interesting with each one of those business events with ease. I don't want to have to go and unpick a massive PL SQL routine to actually do something new with a new event that's occurring in our business. The other one was I really want easy and timely access to master data. If I've got a new idea internally, somebody's got a new idea, or we meet some new third party who's got this new startup, who's got this ultra cool piece of tech we want to use, and they need or they need a product catalog feed, or they need order history. The barrier to entry to that should be, well, here's an API key, go fill your boots. That's really the objective, and the reason for that is these two objectives. They combined. They really drive business agility, and that's the ultimate goal. We want to be able to add new features, new experiences for our consumers really, really, really easily. At the moment, that's just not the case. So boiling that down into some actual architectural principles, what does that mean? Breaking down the existing monolith is important. Decoupling our core systems, kind of the same thing really breaking apart that heritage estate, reduce dependency on batch jobs for all the reasons I articulated. We want to expose our business events, and we want to make our master data much more accessible. On top of that, we want to drive more and better operational simplicity as well. The existing estate, as many of you I'm sure will know, running a big old Oracle estate is not without its challenges, and you've got to be an expert in all of it to be useful on call. And as such, there are very few people in an organization who have those expertise and can develop them. It takes a long time. So we want to reduce that and make our system much more operationally simple. So let's talk a little bit about the solution, or what we think is our solution. So we call this our order pipeline decoupling, and this is where we've adopted AWS and serverless technologies to come up with a new way of doing this. So the starting point is very familiar. We've still got those 3 Oracle systems there. They're not going away. They run important operational services for our business, and frankly, getting rid of them isn't an objective in its own right. Perhaps one day we'll do something different with them, but for now they're sticking around, and getting rid of them isn't really an objective. So they're still there. But what's different? Well, the first thing is that the website is now, its responsibility starts and ends with publishing web orders. As soon as it's got them, as soon as somebody's completed a checkout, it publishes those to this new order event stream in red. It's a Kinesis stream. And that is all it has to do. It doesn't care about anything else. Its only job is to publish to that stream. From there, we have to do an initial bit of validation, just some basic checking that the order's not dodgy, there's no weirdness going on with it, some basic routines. So for that, we've got this order validation microservice. So that's actually been implemented as lambdas, orchestrated as a step function. I'll be talking a little bit about that in more detail in a second. It uses this order reference service, which is a Synchronous API we've created, which just allows it to fetch a few bits of extra information, like product master data, other bits and bobs that it needs to do that validation. And ultimately, the order validation service, its objective is to check that the order's okay, and then spit it out onto another event stream, this valid orders stream. So now I've got two states. I've got an event stream of all of the orders that the website is producing, and I've got all of the validated orders as well. So next step, I now want to take those valid orders, I'm going to consume them, and I need to pump them into our existing Oracle databases and indeed any other services that are interested in the fact that a new valid order has actually been placed. So the first thing we've actually done, and this is a new feature we've implemented, we've got this order shipment router. Its job, and again, it's a step function implementation, its job is to decide essentially where we're going to fulfill this order from. So at the moment, we've got I've shown it on this diagram as 2 event streams, but essentially you'd have 1 event stream per fulfillment avenue, essentially. So the vast majority of ours at the moment, just the way our business is set up, go to our in-house consignments. We fulfill them in our own DC, in our own way. So it's just splitting out those orders, potentially even going to split orders into individual consignments, or routing the whole order. We can implement that logic and we can change that logic. Crucially, if we do change that logic, it's only that step function we have to change. Nothing else gets touched. So we've got those consignments, we've got those events in that, again, in the Kinesis stream, and we now have these 2, so the in-house order processor and in-house warehouse processor. Processors perhaps a bit misleading. I think of them more as adapters, essentially consuming those events and pumping them into our 3 operational systems. In essence, ideally what we will probably do is split out the in-house order processor into 2, because it will be actually much more resilient to have 1 per service, so that we've just got a bit more operational resilience. So from there, we've then got these various systems, again, are publishing events out of the back of them. So gone are these batches. You know, when the OMS, when we've actually completed a dispatch, per order, that's an event. We've dispatched the order, so we publish that event onto an event stream. We also handle returns and indeed sort of short ships or failures to dispatch in the same way. They're just events, business events that have occurred, so we publish them into Kinesis streams. Same thing for picking, pick results as well, the picked consignments. The warehouse management system publishes that as an event. From there, we then want to actually go and capture the payment. So again, it's the same business process, but executed differently. We have this order payment step function. What that's doing is just listening into those event streams. It's doing a little bit of enrichment again and deduplication, just making sure that we haven't already captured the payment for this order. And then it is making use of the RI payment service, which is a synchronous service running in ECS. It's Docker containers with Golang. That is essentially, that's our broker in front of all of our payment providers, third parties. So it exposes a nice friendly API for us to use internally within the business to go and capture payments. So the order payment step function, it just invokes that and says, hey, here's an order, I need you to go and capture the payment for it. And that goes off and does that, talks to our payment service provider, job done. And out the back of it, we get another event stream, settled orders. Again, each order, we get a corresponding event on that event stream. So, looks kind of complicated, but really it's just a logical step. It's a bit kind of crushed down to get it on a slide. What are the advantages, though? I mean, the most obvious one, hopefully, is that we've got all of these business events are now available. You know, if I want to do something new, do something interesting with new orders, or more likely the new validated orders, I can go and say, right, well, let's go, spin up a delivery team. We're going to go and do something new and interesting with that, and we want to send it off to, I don't know, an S3 bucket, or we want to go and do some analysis. I can subscribe to that event stream, and I can do something new and useful with those order events, and I don't have to regression test anything else on this estate. And that is a massive, massive step forward for us. All of that pain has gone away, and I can essentially make those events public within Revryland, potentially even externally as well. So that's a really, really, really big advantage. The other key differentiator here is that if any one of these core systems dies for whatever reason, if our retail merchandising system dies, it doesn't matter. The OMS and warehouse management system, they can continue to consume events off of the event streams. They can continue happy as Larry, and we don't end up with a DC full of people twiddling their thumbs, waiting for somebody on, some poor bugger on call, getting calls from 15 different people in the business, desperate to get the system running again. So we're much, much more resilient. We haven't added any more servers. In fact, we've taken one away. There's no orchestration server in this. We haven't had to provision some database server, any of that. Frankly, I'm not interested in running servers. I'm interested in selling clothes. It makes sense, right? And as a bonus, we've also added business functionality. We can now split the orders if we want to and send them to different fulfillment vendors in future if we want to do that. And we've also made it much, much easier to change the way we handle payments as well, because we've got a dedicated payment service that only handles payments, and it's not bundled up within the order management system as it was before. So I don't need to go and unpick all of that to make changes, which is great. So let's take a little bit of a deeper dive on one of these microservices. So this is the first service in that chain, the order validation microservice. And this is a step function implementation. So as you might expect from the previous slide, it starts by consuming events off of this new order event stream. Every single order that gets placed atomically appears as a single event, so we can consume that in. Now, the first step is we've got this step function invoker. This is actually something we don't want to have. It's a bit of a workaround. So at the moment, it's not possible to invoke a step function directly from a Kinesis stream, which is actually a feature request that I'm sure Bastian's going to help me get sorted out. Put him on the spot. So we had to work around that a little bit. So we subscribed this step function invoker. It listens to the event stream, and it is responsible for triggering the step function. But more than that, it does something else as well. Because we don't want to mark the order or the event on the Kinesis stream as consumed and dealt with until the step function is completed, what this step function invoker has to do is it actually polls the state of the step function as a whole, and will only mark the item on the event stream as consumed and completed once the step function has successfully completed as well. So we have to do that. There is a dead letter queue as well, so in the rare occurrence that some weirdness happens, some parsing error or something, we can dump the event into dead letter queue. We can put alerts and monitoring on that and respond to that if we need to. So we invoke the step function. We do a bit of enrichment I mentioned earlier, calling out to this order reference service. We then move on to the next step, which is to actually execute our validation logic. It's not really important what that logic is. It's just some basic validation routines, usual sort of gubbins. But ultimately, we end up with one of two outcomes. Either it was, yes, the order's fine, or no, there was some validation error or what have you. In either case, the action is very similar. We push that event into a DynamoDB table. Now, why do we do that? We do that primarily for to manage idempotency. We basically deduplication. There are several edge cases in here where we might end up processing the same event more than once by accident. It's relatively rare, but it can happen. And so by putting the event into a DynamoDB table, we can just check that we haven't already processed this event. There is a fringe benefit as well, and that is that with each DynamoDB table, you get what is essentially a Kinesis stream out of the bottom of it with all of the change events in a DynamoDB table, so we don't have to manually go and publish to an event stream ourselves with another Lambda function, although we could do that. There's just no point because we can subscribe directly to the event stream out the bottom of the DynamoDB table, and it's the same API, it's the same. So there are a couple of sort of disadvantages of this. The need to have a step function invoker is one example, and hopefully that's obvious why that's a bit of a pain. The other things we noticed was that in the console, you can actually see the payloads being passed between each of the step functions, and that's really handy. It's base64 encoded. You can go in and have a look at it. That's great for debugging, but if you're processing orders, as we are, or any other entities, that can contain PII data, customer data. And so we didn't think that was a good idea, having that available to all the developers in the console. So to avoid that, what we've done is actually we persist the event itself into an S3 bucket that's encrypted, and we simply pass the ARN between step function steps instead. And that way, the consumer data is never visible in the console to developers. One other thing we spotted as well was that there was for some reason, there's a 32K limit on the size of the messages between these step functions, which is, between the various steps in the function. To my life of me, I have no idea why it's only 32K. Perhaps Bastian can tell us afterwards. That was a bit too small for us. Some of our orders are bigger than that. So what we did, originally we started with compression to try and get around it, but once we switched to putting the payload into S3 and passing the ARN, that problem was solved as well. So that's just one to watch out for. So, it's conscious of time, so I'm going to skip on. So, let's talk a little bit about a synchronous service. Really, this isn't actually a synchronous service, but it's a bit of a weird one. So, we had a requirement to be able to invoke the next step after our order processing system, or OMS, has actually gone and dispatched the item. We needed to then invoke the next step in our big diagram that we saw earlier. These systems are Oracle databases. They can't talk to Kinesis directly. There's no library that lets you do that. What they can do is make HTTP or HTTPS calls. So what we did was we said, OK, we'll put API Gateway as a proxy in front of Kinesis. So now our service that isn't able to talk to Kinesis because it's a bit old hat, it can talk to Kinesis because we can just push events straight into via API Gateway. It sounds a bit kind of janky, but actually it works really, really well. So that's what we've done. And then in the future, if we wanted to do something different with those events, again, we've got all of those dispatch events are there as Kinesis streams that we can either publish to from other sources or consume from other subscribers as well. We also played around with, in this one, executing the logic in just a Golang routine wrapped up in Docker and deployed in ECS. We played around with that just to experiment with different ways of processing. We could have equally done this with step functions, and probably that's what we would do if we were to do it again, because there wasn't any major advantage of doing it this way, just playing around with the different development routes. The question we often get asked, actually, on that subject is, we use ECS. People ask us, why not use Kubernetes? Maybe we will. The reason we haven't done so far is because while there are advantages of running a Kubernetes stack, you also have to have a load of people who know how to run a Kubernetes stack and operate it properly. And those skills are not necessarily flying around all over the place, and it's a new capability that you have to build as a business. And actually, ECS works great. It's relatively straightforward, and all of our developers are quite comfortable using it. So will we use Kubernetes in future for managing Docker containers? Probably, but equally, ECS works great for a starting point as well. So the other little nugget in here is we wanted to make our access to our master data much easier, if you remember. So really, how do we do that, or how does this let us do that? So what we've done is essentially said, okay, we've got all these business events. Let's actually take the data lake strategy and archive all of those business events as they occur straight into S3. We'll dump them into S3, irrespective of whether or not we think they're particularly useful or not, because S3 is super cheap. Sod it, we'll throw it all into S3. So the way we do that is we have, for any given event stream, in this case order events, we have an event subscriber, little Lambda function. We drop the event into S3. We've also played around with enriching that data with data from our heritage estate. And we found the best way to do that, or a really good way of doing that, at least, is to just use plain old JDBC and with AWS batch. Again, serverless way of allowing us to execute routines to enrich our data. Works really well. The other little consideration here is, as I mentioned earlier, these are orders in our use case we're talking about today. So there is PII data in there. And frankly, most of the BI and analytical use cases that we might want to use this data for don't really need that data. So in the spirit of GDPR, which is a pretty hot topic at the moment, what we've also done is we take those events from that raw S3 bucket, which is all encrypted and very few people have the keys to. And as soon as there's a new object in there, we clone it across into a separate bucket, and we essentially run a simple routine in Lambda that cleanses all of the customer data out of it. We do a combination of just removing it and also obfuscating. And ultimately, we get the same event duplicated across into a nice, clean bucket with no PII data, but it's the same event, just with all the masking done. So then that way, we can give the keys to that bucket to loads of different people, and we don't have to worry about proliferation of PII data, which is super cool. So one of the things that we've done with that is, yes, we can give the keys to a third party, and you can give them access to our S3 bucket directly. That's really great. But we've also played around with putting Athena on top of these S3 buckets as well, that lets us put a SQL interface on top of these raw events that exist in our S3 buckets, and there's thousands and thousands of them. And then on top of that, we can put a dashboarding tool. We've actually played around with QuickSight with good success as well, which is Amazon's offering, but there's no reason why you couldn't use any others as well, and we're playing with other tools. So it gives us a really nice pattern for accessing the data associated with all of these orders we're placing and processing, and really is the beginning of our data lake. So, to wrap up, monitoring. One of the questions that I get asked is, how do you instrument a serverless architecture, or predominantly serverless architecture? And the answer is, it's actually pretty easy, although the team might disagree with me. We'll see. This is one of the advantages generally of using Amazon services. CloudWatch metrics, all the basic stuff that you'd expect to be able to instrument and monitor about your infrastructure, and indeed about all of the execution of your Lambda functions in this case and your step functions. All of the metrics associated with the execution path are all there, ready, available, really easy to consume. We use a tool called Grafana. It's a free tool. That's the black graphs there. To aggregate that data and present it. And that gives us a nice operational dashboard to tell us how many events are being processed, basically what's the health of the infrastructure. One thing I would say is that the hardest part is actually figuring out what business metrics do you need to explicitly expose. you know, a lot of the time developers will forget that you actually, you know what, it doesn't really matter if your Lambda functions are being invoked. What really matters is how much money are you making? How, you know, what's the value of these orders that's flowing through, for example? So we can actually expose those as custom metrics in CloudWatch, and again, bring those through into our Grafana dashboards as well. On top of that, I mentioned QuickSight earlier. So this is a little screenshot of a dashboard we've whipped up on top of using using QuickSight on top of Athena, on top of our business events. So this is actually the real dashboard here, and you can see that we can break down for the business and give them a window on what's happening with all these orders. Gone are the days where they have to wait, 24 hours for the cycle jobs to run through and the big batch jobs to run overnight to then have their nice report, on their desk in the morning. They can actually now go into here, and it's pretty much real time. As soon as an order is processed, within reason, you've got that information available in this dashboard as well. So that's really cool. So a couple of little notes about cost. That's another question we get a lot. The cost for operating serverless infrastructure is very, very good. To put it in context, we're now running all of our web orders through this infrastructure, and I think we've barely broken the free usage tier on Lambda. So it's like, I think the monthly forecast for this month is like $25 for Lambda, which is nice. The step functions themselves are a little bit more expensive, but overall we're talking a few hundred bucks a month to run this. One of the biggest line items on our bill is the AWS support, so it's pretty low cost to operate this service. And as I said, this has gone live. We are now processing all of our web orders. It's one of the best go-lives I've ever been involved with because I didn't get any phone calls, and basically the business didn't notice that it had gone live. This, as you guys can tell, is a really, really fundamental shift in the way that we process web orders in our business. Massive, massive change, and basically nobody noticed because it went so smoothly. So full credit to the team for that. I think that's pretty much it, isn't it? So hopefully that's been useful, guys. Obviously, we're going to stick around for some questions. Cool. Question red there.
What make you pick Dynamo over RDS?
It's a good question. Dynamo is, we wanted a NoSQL store to start with as a first step, but also the fact that it was the dynamic scaling is a really good advantage. There are a few different advantages. We could have used a more traditional RDS instance, but there was also the fun of playing with a new tool as well. You could make this work with RDS if you wanted to, but we like Dynamo. It works really well. Sure. Yeah. So the question was, how do we deal with deduping with Kinesis? That's one of the reasons why we're pushing those events into DynamoDB and doing our deduping there programmatically. I don't know if there are any other options for that.
No, that's the best way to do that is use as more the application level. And Kinesis is still a stream, so you have to deal with the possible duplicate.
Cool. So, guys, there's a hand up there. Yep.
Yeah, 2 questions.
Okay.
First one, how much time did you spend creating this infrastructure? And second, CI/CD challenges.
Okay. So, how long did it take us to do this? Had 2 Scrum teams, a lot of this has been built by one Scrum team, but 2 Scrum teams really, and it's taken us, I don't know, like 6 months, something like that. However, prior to that, we've had to build our capability and learn how to use these tools, that has been a multi-year process for River Island to learn how to use cloud services and Amazon services. But the actual execution time when we decided to go and build this, sort of the order of 6 months or so. And the other question was CI/CD challenges. I'm probably not the best person to ask about that. However, there are some of the actual engineers who built this in the room. So if you want to come down to the front later, I'm hoping that a few of them will volunteer to come down and chat with about that as well.
Last question.
Last one, yep.
What were the biggest challenges being compared to the PCI standard?
Say that again, sorry?
What were the biggest challenges being compared to the PCI standard?
What was the biggest PCI challenge? For this implementation, PCI is out of scope really because we're not handling consumer credit card data. We do handle the PII data, which falls under data protection and GDPR. So, and as I say, for that we did take some steps to make sure that the access to that data was controlled, which is one of the reasons why we didn't want to have that data available in the console for any of the developers to look at, because there's no need for them to do that. But PCI wasn't really a consideration because we're not handling credit card data, fortunately, thank God. Cool. All right, guys, I'm going to hang around, but I think we'll wrap it up there. Thanks, guys.